Welcome to the final phase of our Amazon S3 engineering series. Today, we conduct a strict deep dive into storage classes, durability, and automated tiering. For systems architects, a core engineering challenge is balancing aggressive cost optimization against strict retrieval speed mandates and disaster recovery SLAs. Optimizing cloud storage is more complex than routing files to the tier with the lowest cost per gigabyte. This 3D graph plots S3's cost geometry. Every storage class has specific parameters for minimum durations, billable sizes, and retrieval latencies. Ignoring these boundaries has immediate financial consequences. Storing the wrong file type in cold storage will rapidly inflate your AWS bill. We will now evaluate S3's physical baselines, detail the constraints of infrequent access and archive tiers, and map the automated logic of intelligent tiering. To translate cloud primitives into predictable economics, engineers must treat S3 as a sequence of strict mathematical contracts. This topological map outlines a single AWS region. To establish our baseline, we must separate two metrics that are consistently confused: durability and availability. Durability measures physical resilience, the likelihood of your data surviving disk corruption, drive degradation, or complete hardware failure. S3 guarantees 11 nines of durability across all storage classes. Statistically, if you store 10 million objects in S3, you can expect to lose exactly one object once every 10,000 years. AWS achieves this by automatically striping your object data and copying it across these isolated facilities. If a physical storage drive fails, background self-healing processes automatically rebuild the degraded blocks from healthy adjacent nodes. Availability is a distinct behavioral metric. It measures system uptime, how readily accessible the service is at any given moment. S3 standard targets an availability of 99.99%. In operational terms, this means your data may be practically unavailable for up to 53 minutes a year during physical network or data center events. Even when the network drops and the system goes dark, those underlying physical drives remain intact. The core 11 nines of durability are entirely unaffected. Conflating durability and availability results in flawed disaster recovery objectives when selecting specialized, lower-cost storage classes. This decision matrix establishes our architectural options. S3 standard is the baseline default, replicating data across multiple physical availability zones to deliver low latency for active workloads. For data accessed less frequently, but requiring immediate access during an event, standard IA provides 99.9% availability, making it suitable for disaster recovery backups. One zone IA removes the cross-AZ replication, reducing your storage rate by 20% while targeting 99.5% availability. By storing data strictly within a single AZ, you introduce physical risk. If that localized facility is physically destroyed, the data residing on that node is lost permanently. It is intended strictly for recreatable files. Both infrequent access tiers carry hidden financial constraints: a minimum storage duration charge of 30 days and a minimum billable object size of 128 kilobytes. AWS offsets the lower storage costs by charging a retrieval fee per gigabyte processed whenever you access the data. If your architecture dumps millions of tiny logs or highly active files into these tiers, the combination of minimum size penalties and retrieval fees will rapidly outpace any base storage savings. Infrequent access tiers are strict financial contracts. They reward compliance and relentlessly punish misaligned access patterns. For long-term compliance records and deep backups, we abandon the requirement for immediate operational access and shift to the Glacier storage classes. Glacier Instant Retrieval targets data accessed once a quarter. It enforces a 90-day storage minimum, but preserves millisecond access speeds. Glacier Flexible Retrieval lowers the minimum billable object size to 40 kilobytes, but the retrieval logic changes significantly. Flexible Retrieval operates on 3 distinct brackets: expedited retrievals returning data in 1 to 5 minutes, standard taking 3 to 5 hours, and bulk retrievals taking 5 to 12 hours. The architectural advantage here is the bulk tier. You can retrieve terabytes of archive data in 5 to 12 hours completely free of charge. S3 Glacier Deep Archive is the lowest storage rate in the ecosystem. It enforces a strict minimum storage duration of 180 days. The latency trade-off is significant. Standard retrievals take 12 hours, and bulk retrievals take 48 hours to fetch your data. Large-scale users like NASDAQ rely on deep tiers to house 7 years of compliance records, leveraging the minimal storage rate for petabytes of data. Glacier tiers execute a clear exchange. You trade immediate operational liquidity for maximum financial leverage in compliance storage. Defining strict lifecycle rules works for static archives, but variable or unpredictable cloud workloads routinely break manual rule sets. This state machine diagram visualizes S3 intelligent tiering. It resolves unpredictability by acting as an automated lifecycle engine, utilizing continuous object-level monitoring. You pay a small monthly monitoring and auto-tiering fee per object. In exchange, AWS completely eliminates all retrieval charges for those items. The default mechanics are automated. If an object is untouched for 30 consecutive days, the logic gate triggers, dropping the data into the Infrequent Access tier. If access stops for 90 days, the state machine drops the object further into the Archive Instant Access tier. Because all 3 of these default nodes provide millisecond retrieval times, your applications experience 0 latency penalties. Performance remains identical while costs scale down. You can also enable optional deep configurations. These nodes shift objects untouched for up to 700 days into Archive and Deep Archive Access tiers, which do introduce minutes to hours of retrieval latency. Intelligent tiering converts a static storage bin into a dynamic state machine, neutralizing the risk of catastrophic retrieval fee spikes. This vertical flowchart synthesizes these variables into a single decision engine, tracking the data lifecycle from active usage down to cold compliance. S3 Standard anchors active files at roughly 2.3 cents per gigabyte in US East 1. Moving to Standard IA cuts that to roughly 1.25 cents. And One Zone IA pushes the rate exactly to a penny. In the archives, instant retrieval drops to fractions of a cent, and Deep Archive hits rock bottom at $0.00099 per gigabyte. The golden rule of this ecosystem is straightforward. Whenever access patterns are unpredictable, deploy intelligent tiering to let AWS scale your tiers automatically. This technical dashboard tracks the completion of our production-ready storage architecture. In Part 1, we established S3's flat key value namespace, absolute naming limits, and IAM boundaries. In Part 2, we configured static website hosting, mapped the mechanics of object versioning, and deployed asynchronous replication dynamics across regions. Finally, in Part 3, we locked in the complete storage class metrics, calculating physical durability, archive constraints, and automated scaling logic. Mastering these physical and logical layers empowers you to build resilient, cost-optimized architectures on AWS. Thank you for completing this systems engineering series. Keep building.